All right, so what's next on our list? Vertical and horizontal tangents. So if you remember, we have horizontal tangents when our derivative is equal to 0, and vertical tangents when our denominator is equal to 0. And this is all assuming that the opposite is not 0 as well. So if the top is 0 but the bottom's not, well, we get a horizontal. If the bottom's 0 and the top is not 0, we get a vertical. So first thing we need to do then is find our derivative, just like before. So we do dx dt is equal to 3t squared minus 3, and dy dt is equal to 3t squared minus 6t. And then we rewrite it, so we have dy dt over dx dt, so it's 3t squared minus 6t over 3t squared minus 3. And just like with normal derivatives from chapter 3, we want to factor these. So 3t, t minus 2, and I mean by normal is in terms of x. And then here we would get 3t squared minus 1. And so if you remember with t squared minus 1, that is going to give us 3t on top, t minus 2 on the bottom, and 3t minus 1, t plus 1. And then the 3's cancel. So we end up with just that. Now, this just means we take our derivative to find our vertical and horizontal. And we set the top equal to 0 and the bottom equal to 0. So we would get t equals 0 and t equals 2. And then these are our horizontal tangents. And then we get t equals 1 and t equals negative 1, and these are our vertical tangents. Now, we have to make sure that these t values exist. So that means our domain needs to be looked at. And we don't have any input issues here. We can plug any t value we want in here. So all reals, which means we should have 4 different values. So 1 at t equals 0, 1 at t equals 2, 1 at t equals 1, and 1 at t equals negative 1. Now you can plug these in and find the x and y coordinates that give it to you, but that's all we have to do is find them. So we're going to look at the graph and just go through it. So you can see as I'm moving along here, I've got that tangent line with the slope on it. And so we want negative 1 right there. And you can see it disappeared. Our slope is undefined. So our t of negative 1 is our vertical tangent, one of them. And again, if you plug the negative 1 in here and here, it would give you the x and the y coordinates at that point. And you could use that to find the equation of the tangent line, but it's vertical. So if you remember that, that would just be x equals 2. Okay, so then we move on. The next one was 0. And 0 was our horizontal. That checks perfectly. And again, plugging 0 in would give us 0, 0. And then we move on. So again, 1, t equals 1 was our next vertical tangent. And again, you plug it in, it says negative 2, 2. And then our last one was at 2. Right there, and there it is. There's our horizontal tangent again, and 0. So they all work perfectly. All right, let's try another one. So here we have x equals cosine and y equals sine, which gives us our circle. We showed that before. And our t here is not t, it's theta. So I got to change that to theta. There we go. We can use any parameter we want. So now we would get dx d theta is equal to a negative sine theta, and dy d theta would be cosine theta. So our dy dx is going to be cosine theta over negative sine theta. Okay, so now to find the vertical and horizontal tangents, again, we take the top, set it equal to 0. Those are our horizontal. And we take the bottom, set it equal to 0. And then those are our vertical tangents. So let's start with the bottom. We already know sine of theta is equal to 0 at theta equals 0 and pi. You can kind of just ignore the negative because we're just making it 0. So at 0, we're going to get 0. Remember, the negative just reciprocals it. It's not going to reciprocal these values. So that means we would have 0 plus 2 pi k and pi plus 2 pi k. And so putting those together, we just get 0 plus pi k, which is really just pi k. So we're going to get our vertical tangents at pi k. And cosine theta is 0 at pi over 2. And then it would also happen again at 3 pi over 2. So using that same rule, we're just going to do pi over 2 plus pi k, every pi. So you remember with our functions, it's the y coordinate for sine, so it would be 0 here and 0 here. So it's 0 and pi. And cosine is here, is 0, so it'd be 0 here and here and then here. And so it's just going to keep repeating and repeating and repeating. So these would be our horizontal tangents. So when theta is equal to pi over 2 plus pi k, we get a horizontal tangent. And when theta equals pi k, we get a vertical tangent. So as t moves around here, you can see that every single time it hits these t values, we're getting those vertical, horizontal, and so on. So you can see here, when t is 0, we're at 1, 0, because it's a nice perfect unit circle. And we have undefined. And then if I go to pi over 2, horizontal, vertical, horizontal, vertical, horizontal, it's just going to continue and going the other direction as well, even in the negatives, since the pi k, and where k is an integer. And so as it moves around our circle, it's just going to go through every single time it hits those points. We're going to go back and forth between vertical, horizontal, vertical, horizontal, vertical, horizontal, vertical, horizontal, and so on all the way around. All right, and so those are our horizontal and vertical tangents.